Hello friends, I welcome you all to this session on graph theory. So today what I'll be doing is I will be discussing few more theorems and then we'll be solving one or two problems to understand those theorems. So let us start with the session. So consider these graphs. So now what is your observation about these graphs? The first thing which you can see is that all the graphs which I have drawn, they all are simple graphs. Okay. Now, if one evaluates the degree for all the graphs, then uh, here this vertex is of degree 2, this is having degree 3, this is having degree 3, this is having degree 3, and this is having degree 3. Likewise, for the second graph, this is 2 degree, this is 3, 3, and 2. This one is 2, 2, 2, and 1, 2, 3, 4. So this is 4, and this is also 4. Now, list the number of vertices in each graph. So it is 1, 2, 3, 4, 5. So this is n5. This is 1, 2, 3, 4. This is n4. This is 1, 2, 3, 4, 5. So this is n5. Now, one thing which we can observe is that in any simple graph, the number of the maximum degree of any vertex will always be less than or at most equal to the number of vertices minus 1. So, the maximum degree of any vertex in simple graph can be n minus 1. So here, as the number of vertex is 5, so it should be n minus 1 should be 4. So the maximum degree which any vertex in this particular graph can have is 4. And we can see that all the vertices in this graph are either having or they are having degree less than 4. So this is again a valid graph. Now, in this particular graph, if you see that all the vertices are having degree uh, less than or equal to n minus 1, that is 3. So therefore, again, this is what we can see from this graph. And here in this particular graph also, the maximum degree is 4 and all other vertices are having degree less than 4. So the maximum degree which any simple graph can have, any vertex in a simple graph can have, is n minus 1. So this is your theorem. Likewise, if you can count the number of edges in these graphs, so let's say in this graph it is 1, 2, 3, 4, 5, 6, 7. So m is 7 in this graph. This is 1, 2, 3, 4, 5. So here m is 5. Here 1, 2, 3, 4, 5, 6, and 7. Here m is 7. Now, the fourth theorem says that the maximum number of edges in any simple graph can be nc2, that is n minus 1 by 2. So these are the maximum number of edges any graph can have. So if you look this particular graph, there are 5 vertices. So 5 into 4, 5 minus 1, that is 4, divided by 2. So this graph can have a maximum of 10 edges. And how many edges does it have? 7. So this is possible. Likewise, if you look this graph, then this graph can have a maximum of 4 times 3 by 2, that is 6 edges. And how many edges do we have? 5. So again, possible. And if you look this particular graph, then we can say that the maximum number of edges this particular graph can have is 7 times 6 by 2, that is 21. Have I written correctly? No, it is wrong. So it should be the number is 5, not 7. So it is 5 times 4 by 2. So it is 10. And here it is given to me that the maximum number of vertices is 10 and the given number of vertices are 7. So again, this is a possible case for simple graph. So in any simple graph, the maximum number of vertices can be n minus 1 by 2. Okay, so these are two particular theorems. Apart from this, if you look this closely and try to make this simple graph a complete graph, then in that particular case, the degree will be exactly n minus 1 for every vertex, as that is a complete graph, and the number of edges will come out to be exactly n minus 1 by 2. So let us also see this. Let's say this is what? This is a complete graph. Okay. And how many vertices are there? 3. How many edges are there? 1, 2, 3. So from the theorem, the maximum degree can be n minus 1, that is 2. So here its degree is 2, its degree is 2, its degree is 2. And as this is a complete, so it should be exactly equal to 2. The maximum number of uh, edges in any simple graph is this, and in case of complete graph, it should be exactly equal to 2. This number, that is n minus 1 by 2, that is 3 times 3 minus 1 by 2, that is 3. And here we are having 3. You can take one more example. Now this is again a complete graph. How many vertices are there? 4. How many edges are there? 1, 2, 3, 4, 5, 6. So according to the theorem, the maximum degree or the degree of every vertex in this complete graph should be n minus 1. So it is 3. And the edges should be equal to n minus 1 by 2, that is 4 into 4 minus 1, that is 3, divided by 2 and 6. And hence you can see, whereas the degree, it is having 3 degree, 3 degree, 3 degree and 3 degree. So remember that whenever you are having a simple graph, then the maximum number of edges in that particular graph can be n minus 1 by 2, whereas the degree for any vertex cannot exceed n minus 1. And if that graph is a complete graph, then the degree will be exactly n minus 1 for every vertex, and the number of edges should be n minus 1 by 2. Exactly. Now let us solve some problems related to these two theorems. So it is given to us, let's say that we are having a graph G for which 6 vertices are there. So how many vertices? 6. So n is 6. And the degree for the vertices is 2, 3, 3, 1, 4 and 3. So this is what the degree for every vertex in that particular graph is. And it has been asked to find out that whether this particular graph is a valid graph or not. Okay, so what we can do is, we can do many things, but let us try to understand from the point of view of what we have learned so far. So let us start with the total degree. Total degree will be equal to 2 plus 3 plus 3 plus 1 plus 4 plus 3. So 3 plus 3 6 plus 4 10 plus 4 14 plus 2 16. And this is even. So it seems to be possible. But again, we have to check how many vertices are there in this particular graph which are having odd degree. So 1, 2, 3, 4. So 4 vertices are there whose degree is odd. So therefore this number 4 is even. So again this is possible. Okay, now this is a possible case. Now the author is asking that how many edges does this graph have? So we know twice the number of edges will be equal to the sum of degree of all the vertices in that graph. So this is 16, this is 2m. So m will come out as 16 by 2, that is 8. Okay, now take another case. Another question let us do. Let's say that we are having a graph with 8 vertices. Let's say the number of vertices is 8. So n is 8. Okay, and there are 30 edges. So m is 30. Now the question is it possible that this graph can be a simple graph? So now in any simple graph, we know the maximum number of edges can be n minus 1 by 2. So n is 8, n minus 1 is 7, so divided by 2, and this is 28. Okay, so the maximum number of edges in a graph having 8 vertices, and that too if it has to be a simple graph, then this should be number 28. But the problem says that the graph is having 30 edges and still it is simple. So is it possible? No, it is not possible. Hence the graph, such type of graph is not possible. Why? Because not possible in the sense that it cannot be a simple graph. So if I am having a simple graph, then the maximum number of edges for 8 vertices can be 28. And if I am saying that I am having a graph which is simple also, and at the same time 30 edges are there and 8 vertices, so that is not possible. So the answer to the question is we cannot have a graph with 8 vertices and that graph is simple also and that is having 30 edges. So that is not possible. So in this lecture, till this point only, in the next lecture, we will be learning about the theorem called as Havel-Hakimi theorem. Thank you very much for watching it.